Okay, on to evaluating polynomials. Right, here we go. Now, sometimes it's just understanding that what they actually want. Now, look at this equation. P of A. I know normally we see f of x. Okay, I always like to think of things like this, keep it kind of fairly standard. F of x. Okay, that's kind of how we'd normally see it. But anyway, what this is trying to say is this. Look, P of A. What we want is P of 8. Nearly sounds the same. Okay, in other words, I'm replacing the letter A with the number 8. There is the only place where there's an A. I'm going to replace that with an 8. So think about it. 15 take away. What's 2 times 8? 2 times 8 is 16. So this term will end up being 16. 2 times 8. 15 take away 16. Okay, is negative 1. Okay, so that's that one. Now how about something with some squares in it? G of x, this one here. Now, g of negative 2, this is saying that x is going to be replaced with negative 2, okay? Both here and here. Right, let's have a look at this. So, 2 times by negative 2 squared. Instead of x squared, it's negative 2 squared, okay, this little bit here. Minus 3 times x, which again is negative 2. And then at the end, it's just plus 4, okay? Just a plus 4 at the end. Sorry about squeezing that in there. Right, bit by bit. Okay, please do not go 2 times negative 2 at the start. It's negative 2 squared, okay? Orders of operation. I'm going to do this first, okay? Negative 2 squared is 4. I'm still going to have to multiply by 2 at the front here, okay? So, all of this here is going to be 8. Right over here, right, 8. Okay, right, I've done that bit. Right, look at this, negative 3, negative 2, multiplication. Negative 3 times negative 2 is a positive 6. And then add the 4 at the end. No x there, it's just add a 4. 8 plus 6, 18? The answer is 18. So watch that one, especially with negatives in it. The negative 2, you've got to square it. I've got the second term as a negative 3 times a negative 2, so 2 negatives. So that's how you do that. Now, sometimes like, why? Well, have a look at this. Here we go. Here's an equation. Stopping distance in feet for a car moving at a velocity. Right. So here's the equation. What we want to know is what's the distance in feet? Okay. The distance when I'm going a certain velocity v. Now here, this is saying, okay, if I'm going 55 miles an hour, what's my stopping distance? Okay, I'm going to need a calculator for this, but I'm going to put 55 right there where the v is. Oh, there's 2 v's, okay? It's going to go there, sorry about my 55s, and it's going to go there. Right, be careful. Okay, so I'm going to write it out. 0.04 times v squared. So I'm going to do the 55 squared first, remember, okay? And I'm going to add 1.1 times 55, and that's just v, that's no squared, okay? Okay, I need a calculator for this. Right, so what's 55? I'll just do times 55 again. Equals, right, that's what it is. Multiplied by 0.04 equals, you can write that down if you want to, I'll write that down. Well, that's 121. The whole of that there was 121. Calculator. Right, if I want to kind of just clear that, you do bits and pieces, sometimes you're not sure how to put it into a calculator. Right, 1.1 times 55 equals, that part here, was that 60.5? Let's have a look. Okay, let's add that 121. 181.5 feet. Okay, so there it is. That is 181.5 feet. That's your stopping distance. Now interpret the meaning of this value, interpret d of 8. Okay, so d of 80 means put 80 in there. Obviously it's going to be much bigger, the stopping distance. But that's their use of evaluating polynomials. Okay.